I have fixed over 300 Synology NAS units, and I'm going to show you how to fix all the common faults with this DS1813 Plus. The two common faults we see are dead no power, which is what we're experiencing today, and the unit boots up. We do get a blue blinking light, but it doesn't actually initialize and cannot be detected on the network. Our first step, let's open it up and take a closer look inside. First, I'm going to flip it to the back, and we'll remove the 6 cover screws. To remove the cover, I'm going to slide it back and wiggle it off. Next, I'm going to flip the unit completely over and remove these 3 silver screws. Next, we flip it back over and we'll remove these 4 screws. Now we can remove the fans. There are 2 plugs. We'll just wiggle those out and we'll put this to the side. Our first diagnostic is to rule out the power supply. Now, to be clear, the power supply doesn't actually commonly fail with these units, but we do want to first rule it out. To do that, we're going to isolate it by disconnecting the motherboard, and we're going to flip it over. We're going to disconnect the back plane. Let's plug it into power. We're going to zoom in just a little. I'm going to use a black wire for my ground. The green one, which is our PS online, we want to make sure we have voltages there, which we are getting 4.26 volts. And because the power supply is off, we should not be getting any other voltages anywhere else. And we are not. In order to fully turn on the power supply, we need to short the PS online to ground. So I'm using a jumper wire. We're still going to use that same ground to take a voltage measurement, and let's see what voltages we get. From our orange wire, we're getting 3.3. Our red wire is showing 5 volts. Our gray wire in the back is also showing 5 volts. Our purple is 5 volts, and our yellow is showing 12 volts. That tells me all of the output voltages expected from the power supply are present, which does confirm to me the power supply is most likely not the issue. So now we can remove our jumper wire and the power cable from the power supply and take a closer look at the motherboard, which is the most common cause of a dead no power fault. We've already removed the power supply cable, so next we'll do the front panel connector, and finally our fans. We'll flip the unit over and remove the 5 screws. Now I'm going to wiggle the motherboard out, and here we are. These are the 4 parts I'll be installing in the unit today. And if you're trying to fix your unit yourself, I'll have these available as a repair kit that you can purchase on our website, and I'll link that in the description down below. There are 2 parts on this motherboard that can fail and cause a no power issue. Number 1, the CMOS battery just down here. So let's replace it first. Let's do a quick voltage measurement, and we are getting 3 volts. Now the customer did state they had to replace the battery before sending in the unit, but if you're getting less than 3 volts, I would encourage you to replace it. Now the second common reason for a no power fault is defective capacitors. More specifically, right here. As you can see, we have the capacitor at ID location C392, and it's physically cracked. I can see damage on it here. So it's burnt up, and in parallel, we have C390 over here, and you can also see it's very burnt up. In contrast, here are the capacitors that are not damaged. These capacitors are rated for 10 microfarad and 16 volts, and we're actually going to replace them with 10 microfarad 25 volt rated capacitors. I'm going to rotate the board a little bit to make it easier for my soldering angle, and I'm going to add solder to both sides, get good flow, and knock it off. Next, I'm going to use my desolder wick to remove all that solder, a little isopropyl alcohol, and a Q-tip to wipe it off. Now this one was pretty easy. This next one will not be so easy. Now the reason it won't be so easy is A, it is in a little bit of a cramped space, so it's going to be harder for me to desolder it, but B, it's also burnt up and has damaged the board, the capacitor, and the trace. And that always makes it harder to desolder. Okay, it looks like it actually broke in half, so I just removed half of the capacitor. I'm gonna give it a little bit of a clean, even though obviously we still have the other half to remove. And we're gonna try and flood this whole area with solder. See if we can get some flow. And I don't think I'll get that flow I'm looking for. Sometimes when these capacitors burn up, they can actually fuse themselves to the board in a way that it doesn't matter how much heat I apply to the joint, it simply will not desolder. So I may have to break it off. Okay, let's give that one more clean. All right, so here's what we'll do. Let's zoom in a little more actually. So using my little Dremel tool here, I'm going to expose a little bit of the copper around that trace. And using the multimeter in continuity mode, when I have a short, I have a beep. So I'm gonna take a measurement from this leg right here to here, and it does look like it connects. So that means that I can actually, instead of using this pad here, I can connect my capacitor from here to right here. So for that, I'm going to desolder that pad a little bit more because I still have a little solder. I want to make sure it's nice and clean. And then I'm going to add a little bit of extra solder to the leg of that component. So we've rotated the board just one more time to make the angle a little easier for me. We're going to melt our solder, slide in the capacitor, and I'm not getting the flow I'm looking for. Oh, there we go, perfect. All right, so we have definitely good contact on that pad. Let's add just a tiny little more here. Okay, that's better. I have a little bit of a solder horn, so I'm gonna add some flux, and let's just do it to both sides. And let's touch it up one more time. Oh, beautiful. Yep, that's perfect. Final cleanup. We'll want to get rid of some of that flux I just added. All right, let's move on to the next one. This one should be much easier. Let's go ahead and add some solder to one of the pads. We'll melt the pad, slide in our capacitor, rotate the board, and let's solder in the other side next. Perfect. Same thing, we have a little bit of a horn, so let's add just a tiny bit of flux and touch up the joint. Perfect. Same thing, little cleanup. We'll place the motherboard back into the unit. Let's connect the front panel connector, the power connector, and we don't have to plug in the fans. I'm plugging in the unit. Let's take a look. Hey, we have a blue light. We did not have that before. Okay, we can disconnect. So we have resolved the dead no power. We now have a blue blinking light. However, before we fully initialize and put it back together, I do want to show you all of the common fixes. So next we're going to tackle the problem of the blue light blinking endlessly, never actually initializing or being detectable on the network. Let's disconnect the motherboard one more time and remove it out of circuit. This next part is going to require the removal of the DOM, which is disk on module. To do that, I'm going to pinch the plastic clip here and wiggle up the DOM and out, just like that. If we flip the DOM over, we'll see a chip over here. This is the microcontroller. The microcontroller is the component that typically fails on this DOM and the one we will be replacing. Now in our scenario, it's a Phison branded chip. There are two other manufacturers, ITE and US Best. We typically only will want to replace the one that's made by US Best, which is the chip that we provide in our repair kit. If your microcontroller is branded Phison or ITE and you replace it with a US Best microcontroller, that will actually break the DOM and it will no longer work. So do not do that. It is labeled US Best UT165-L48, and very importantly, it says A0A. Now, if you have a chip that's different than this on your daughter board, then most likely it is not at fault. If you have this exact same chip as I do here today, then it is the most likely culprit for the blue light blinking endlessly. We're going to start by adding some solder first to all the pins. The unit we are fixing had a Phison branded chip, so we don't want to replace it. But for the purposes of this video, I'm showing you the replacement process from a failed DOM that belongs to a different unit. Next, I'm going to add some flux. And for the removal, we're going to be using both the hot air and the iron at the same time. So as I'm using the hot air, I'm also going to use my iron. Now the board is very light, so as you can see, it's moving around. Oh, there we go. It looks like we have movement. We'll knock off the board, or the chip off the board. We'll go ahead and remove the solder off the pads. And again, a little cleanup with isopropyl alcohol. We want to remove all that spent flux. We're going to add just a little bit of solder to one of the pins. You'll notice I have an arrow and a circle here, which indicates pin 1. And I also have a circle on that same corner on the chip itself, indicating pin 1. Okay, we'll slide it in. Whoa. Is that good? It's not perfect, so we'll need to make an adjustment. But that's why we're only locking in one pin at a time. Okay, that looks pretty good to me. So now let's lock in a couple more pins. We'll add flux to all 4 sides again. And we're gonna start with that side I added probably a little bit too much solder to. And we'll try to spread that around. Fortunately, it looks like I can't get rid of all that extra solder, so we'll need to use the desolder wick to get rid of some of it. Well, there we go. I do have a little extra on this side as well. Aha. And our final side. There we go. Again, a little cleanup with isopropyl alcohol. Something I like to do to confirm my soldering work was done correctly is to rake, and what that means essentially is putting pressure on every pin. And if any of them move, that would tell me that they're not correctly soldered in. And if none of them move, that means I did my job correctly. So far, so good. Okay, we're all set. Now that we've completed all the repairs, let's reassemble the unit and give it a final test. I'm gonna connect the front panel first, flip the board over, and install it back into the unit. Now we still do need to reconnect our power supply to the backplane. And finally, we can put the cover back on. Plug it in one more time and power it on. So our blue light is on, it is blinking. Our fans are spinning. Let's wait a couple minutes for it to boot in. Our unit has finished initializing. It is now detectable on the network, and that does complete our installation of the repair kit. If you would like to try to install the kit yourself, we'll have those available for sale on our website, and I'll have links for that in the description down below. As well, if you're not comfortable trying to install that kit yourself, we do offer flat rate services, which come with a 1-year warranty. Those are also available on our website, which I'll also link in the description below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.